essentially were dying. Whole stands were dying, or a majority of stands were dying. And some of the earliest of that occurred in eastern Oregon. It's going on today still here in eastern Washington. We have a lot of spruce budworm outbreaks on the Wenatchee National Forest, for example, and the Okanagan National Forest. And so basically, you just cannot sustain dense, high basal area stands in these mixed conifer sites. They're going to be at risk. Second thing we found out was, guess what? You build up a stand like this, and you do get an ignition, and the fire gets hold, the whole damn stand's going to burn. It's going to burn in a stand replacement kind of fire. Instead of a low-intensity fire, it's going to burn, and it's going to burn up everything, including these big fire-resistant pine trees, because you've got so much fuel around them. Yet again, another thing that we discovered is even if you don't burn up the big pine trees, the competition from all of the grand firs and Doug firs are going to stress them, and they're going to be more vulnerable to bark beetles. So one way or another, the old growth trees are at risk. And yet, of course, these are several things. These are the structural backbone of these ecosystems. These are the pine, the big pine, are the trees that provide the big living trees, the big snags, the big down logs, critical habitat for the characteristic organisms. They are the fire-resistant trees. They are the drought-resistant trees. If you do get a fire or an insect outbreak in here, these are the ones most likely to survive. So, obviously then, you know, we've got some real issues. We've dramatically altered the system. We've made it much more vulnerable to various kinds of events, insects, fire, and we've put the most important single structural element of the forest at risk. So today, you know, we're in a very different place. And what we're trying to do on the federal lands for the most part is to begin to restore health to these pine forests and mixed conifer forests. And there are ponderosa pine sites where you don't have the Doug fir and the white fir, but where you do, because of the absence of fire, have the same problems with overstocked stands and the potential for high-intensity fire. And so the question is now, what are you going to do? How are you going to do it? And it is restoration dry forest style, as opposed to restoration west side style, as we were looking at in terms of those restoration thinnings yesterday. And in these, it's much clearer what is at risk. The need for doing something is much clearer here. As Andrew and I told you in the Douglas fir, if you don't do anything with the plantations but just leave them alone, it's okay. It will work out. It will sort itself out. You will get the habitat. But if you don't do something about this, you will lose it all. You will lose it all. And in any case, what you're going to have to do is you're going to have to put in some really aggressive kinds of efforts to try to restore more of the characteristic of the historic and, I might add, sustainable ecosystem here. And so that's what restoration is about in the dry forest. It's about trying to begin to restore a more characteristic structure, trying to restore certainly fire as an important contributing rather than destructive element of the system. And it's probably the biggest challenge that we're kind of looking at this point in time in terms of management of the public lands. And this is pretty much an issue all over western North America with the pine, and I include in that the pine forests where the pine was sustained by fire and it's fundamentally a more productive mixed conifer type. Okay? And in fact, it's sites like this which are relatively productive and where the pine is not climax where it's most important to get going on it earliest because it's where you have more at risk. So questions about history here. Scott?
How much do you change the dynamics of the soil when you alter forest structure, composition, or change the dominant species?
You change it dramatically. Particularly in this case, it's largely a consequence of the understory. And basically, you've altered it from a site where you had a very significant understory of herbs and grasses to one in which now you have a closed canopy conifer forest, and it totally alters the kind of cycling processes, the way organic matter is getting into the soil. And to a certain extent, and the place where I sort of learned to sometimes think about it this way, is that a lot of these forests were fundamentally a grassland with some pine trees in them. And you know that grasslands have very different kinds of soils than forests do, because of the fact that you have a lot of roots. That basically the grasses are contributing largely through root production and incorporates the organic matter in a very different way than in a conifer forest or a forest of any kind where the litter's coming down and it's all near the surface. You get a very different kind of profile, different kind of chemistry. So it does change the soil properties.
Is there any effect of like way that pine roots would be different than Douglas fir roots?
Not necessarily. Other than pine, Ponderosa pine tend to be a strongly taprooted species. So instead of being a surface feeder, they tend to be a deep feeder. Okay. Douglas fir also tends to develop a pretty good taproot. Grand fir doesn't generally develop a very good taproot, and so different tree species can be more taproot, feed deeply. Other species like hemlock, for example, are surface feeders. They generally don't tend to have taproots. They tend to put out a lot of surface roots. Now, one of the things that happens when you suppress fire is that there's a tendency for even the pine to begin to be more of a surface feeder. And one of the issues for us as we try to return fire to the forest is that those initial prescribed burns often damage or destroy a significant part of that root system. And so that's a real issue, and one of the things we've learned is that the first reintroductions of fire can really shock the system, and you can get reduced growth and mortality as a result of just the damage to the roots, which have altered where they are in the soil. So it's a real issue. And we'll also point out some other issues with reintroducing fire. One of them tends to be the accumulation of material right around trees, bark right around trees. So you have to be really careful when you go and begin to try to reintroduce fire to a system. And obviously, it should be obvious, but I know some folks who don't seem to appreciate that, is You know, you just can't go out here and start torching this forest.